A block of mass m equal 1000 kg is being pulled across the surface, connected to a tractor by a spring of stiffness K equal 4900 Newton over meter, and a relaxed length L0 is 4 meter. The whole assemblage moves with constant speed V equals 3 meter per second. The coefficient of sliding friction between the block and the ground is UK equal 0.5, while the coefficient of static friction is US equal 0.75. The first question is draw a force body diagram and label all of the force acting on the block. The relative length of your arrow should scale with the force so that if one force is twice as large as another, its arrow will be twice as long. So first we can draw the force of gravity on the block because it is really clear since force of gravity is just mg. And so first we draw a point particle which represents the block. Then we draw a downward force which will be the force of gravity, and it is Earth who make this force to the block. And then since it is constant speed, so the net force in the y direction is 0. So the normal force by the surface is equal to the mg. So we draw a equal line with opposite direction and label it Fn. And the surface make this force. And then, since the block moves with constant speed, we will use a sliding friction, which is 0.5. And the friction will be the coefficient times the normal force. Since the coefficient is 0.5, so the force of friction will be half as the normal force. So we approximately draw a line that is half of the normal force, and label it FF, and it is a friction. And also, in the same axis, the spring exert a force on the block in the x direction. So we will draw an equal line with opposite direction and label it FF. And this is a force exerted by the spring. And this is our first problem. Second, calculate the length L of the spring as the block slide along the ground. So the first we need to do is calculate the Fg. Fg equals mg equals 1000 kg times 9.8 meter per second square, and Fg equals 9800 Newton. Since it is in the constant speed, so the net force in the y and x direction will be 0. And we focus on the y direction, so dpy equals dt equals f net y. And since the left side of the equation is 0, and the net force is Fn minus Fg, since these are the two forces that cancel each other out in the y direction. So Fn equals Fg equals 9800 newtons. And then we use this normal force to calculate the friction of the surface on the block. The equation for the friction is F equals UK times Fn. Since it is in the constant speed, we use a sliding friction, and we plug in the number 0.5 times 9800 newtons, and it equals 4900 newtons. And it is in the constant speed, the net force is 0, so in the x direction, the net force is 0. So we write dpx over dt equal Fnet x, and on the left side 0 equals Fs minus Ff, because this is the two forces that cancel each other out. And Fs equals Ff equals 4900 newtons. And then we need to calculate the length of the spring, which we use this formula. F magnitude of F equals Ks times S. Fs times Ks times S. Fs equals Ks, and S we express to L minus L0, which is a relaxed length, and we plug in the number, which is 4900 newtons equals 4900 newtons over meter, because this is the number we got from the question, times L minus 4 meter, and we get 1 meter equals L minus 4 meter. L equals 4 meter. And this is the answer we got for the number 2. And then we jump to number C. And suppose the block is detached from the tractor and lifted by a crane using the same spring as the block bobs up and down, determining the period of oscillation. So we use this formula since it is in the period of oscillation, which is T equals 2 pi over W. And then we may change this expression to 2 pi times M over Ks. And we just plug in the number 2 pi times square root of 1000 kilogram over 4900 newton over meter, and T equals 2.838 seconds. And this is the answer we got for the question number 4.